So, we are going to talk about what is the digital twin of the ocean, actually plural. And I will cover some of the technology applications and the benefits, but this is something that you will learn a lot more about during the entire summer school, of course. So this is just a starting taste, you might say. So the introduction is then we are going to say a few words about twins, the role and importance of twins, and as I said, some of the components that it goes into a digital twin. So my background is astrophysics, so it's natural for me to start with the universe. And as a theoretical exercise, what if you could ask, what if we could create a parallel universe? Not the one that Einstein, etc., was talking about, but just, to play with the universe. We all understand that that is way too complicated. We don't know actually that much about the universe, just a fraction. So we don't do that. But let's go zoom in on the Earth. How about making a digital twin of the Earth, a parallel Earth? And even that will be complicated. It's funny because when I was an astrophysicist, we were having fun by saying, oh, we are very happy we can ignore planet Earth because it's so complicated. And in a universe perspective, it's not even noise. And here I am talking about the Earth and diving into the complexity of our system Earth. So even creating a digital twin of the Earth is complicated. Now, we are focusing on the ocean. And I would say that even the ocean, the covering 70%, the surface is 70% ocean, and it's the part of the Earth that we know the least about. And this is, again, what we try to make a digital twin of. Now, a digital twin in Iliad is then focusing in, as you can imagine, then we are trying to zoom in even more. So we are focusing on more local areas and we are focusing on more specific thematic areas. And I'll come back to that. Now you will hear through my speak now that there are multiple definitions and ways of talking about the digital twin and what is a twin, what is an ocean twin, etc. Here you see the definition, description made by digital twins of the ocean activity in the Ocean Decade program, DITTO, which Iliad is contributing to and are active in. So very simply said, we want to create an ocean that is a virtual representation of the real world. Moreover, you see on top here that digital twins of the ocean are virtual representation of the real ocean, and it has a two-way connection with it. This is important, and this is partly what distinguishes digital twins from the regular applications and services that you know from now. It's really a two-way connection. And we are using observations from the real ocean and change and continuously redefine the twin. And we can also manipulate the twin to highlight different regions of the real ocean in need of a better or different observations. The digital twins will enable what-if questions to be answered based on real data, shared data, and models and knowledge. And it's a very powerful tool for ocean professionals, for citizen scientists, policymakers, and for us all in general to visualize and explore ocean knowledge, data models, and forecasts. Taking that, I said, we really acknowledge that we do know a little about the ocean after all. By twins, we will learn more. We will then provide and make the ocean accessible with open and equitable access to the data, information, and technology and innovation. And innovation is important for Iliad. So we are then developing a comprehensive digital representation of the ocean that are also interactive. Here, yet another perspective. Um, we are modeling, we have a virtual modeling of a physical object or system that replicates its behavior and also the processes in real time. Um, Real time is a concept that is also varies from sub seconds to weeks, just to say that. But it is really a powerful tool to look at the ocean in real time. We integrate the components, and we will come definitely further into that. We integrate data, both real time and historical data from sensors, satellites, and various other sources, and we will talk about that as well. We have simulation models, advanced algorithms that replicate ocean dynamics, and we are also integrating the use of artificial intelligence. The user interface is of great importance. The different users will have different needs and requirements on the user interface. Some experts users will want to have more direct access to the models itself. Others don't care that much about how you get the results. They will just see visualization or be able to play with it by changing a few parameters, and so it will be very, very different, and it will be installed in different contexts as well. A scientist will use it on his desktop. The ship, a captain on a ship will use the bridge, the instruments on the bridge, etc. And we also have then the real-time monitoring. It provides real-time monitoring and the feedback loops. The feedback loops, as I said, is very important because that is then allowing us to steadily improve the virtual representation of the physical ocean and the activities that we are looking more closely at. Yet again, a digital twin is a digital or virtual copy of the physical assets or products, and I will add, and the interactions between them and the processes that humans are also doing on and with the ocean. So it's a connection between the real and virtual worlds, and it's collecting data real time from installed sensors. In Iliad, we are using both existing sensor networks, but we are also adding new sensors to this digital twins of the ocean system. We run models and produce both short and medium-term forecasts, and we produce and analyze big data in all its definitions, both internally and externally. We are using Internet of Things technologies to transfer the data, and we are using cloud services, but we are also using cloud services, local and centralized. And we are representing a virtual copy of the performance and operation of physical assets. And the automation of the processes and the optimization of the procedures are providing great value. So the digital twins are a very valuable assets for us. So who and why, first is why. Why do we want to make the digital twin of the ocean? Well, here are some of the areas. Environmental conservation. We monitor and we can protect marine ecosystems by having better knowledge about the system itself. Understanding and mitigating the impacts of climate change. And that goes both for aerial coastal planning, for aquaculture, and many other activities that we are doing. Mitigating and understanding the impacts of climate change is super important. And then in general, resource management, sustainable use of the ocean resources like fisheries and minerals. So fisheries, of course, the Sustainable Development Goal for zero hunger, and the ocean and fisheries, they are an important part of the solution for that. Balancing economic activities with environmental protection. Very often we have conflicts of interest, and it's very hard to look at the system that it's very complex with many interests at the same time. So if you have a digital twin, you can actually play with different scenarios and base your decision on as much fact as possible in a holistic way. So you take into account the different interests based on facts. Disaster preparedness. So predicting and responding to natural disasters such as tsunamis and storms and sea level rise. And as I'm from Norway, algae bloom, harmful algae bloom. And I guess that's also important in Ireland, by the way, and many other places. Scientific research. So I think many of you are on a scientific path, and a digital twin in itself for science and research is also very useful. You can enhance your understanding of the ocean processes, and you can provide a platform for testing hypotheses and models. And in fact, I just learned that and one way of doing it is that you collect some information about your area of interest in the ocean, and then you look at it, you can identify places, you can faster understand which hypothesis that is smart to ask, and that you will faster reach an understanding of the problem you are addressing. It's also, for scientists and for scientific purposes, it's also a very good way of developing scientific intuition. By playing with the digital twin, you can develop this scientific intuition. And last but not least, the public awareness and education. In order for us to be able to spend resources on protecting the ocean, we are reliant on the public interest and understanding of it. So engaging the public and policymakers with visual and interactive data is another area of great importance, and why we want to make digital twins of the ocean. As I said, in Iliad, we are not zooming in only on the ocean. We are not only zooming in on various specific locations. We are also addressing specific thematic areas. So here you see the main thematic areas that we are addressing with concrete twins in Iliad. There are 12 areas, and it covers coastal sediment, ocean energy potential, and I believe you will focus a lot on energy in this particular summer school. Met-ocean hind now and forecasting, ballast water monitoring, and harbor safety, existing wind farm capacity, jellyfish swarm forecast. But by the way, that is a citizen science-based and driven project. Pilot, oil spill simulation, plastic pollution monitoring, fisheries and sustainable aquaculture, marine and maritime insurance, aquaculture, water quality, and ship traffic. So you see there's a lot of different activities that we create, then digital twins that will help us solve or address specific problems. So who is using the digital twins of the ocean, and for what purpose? Now, I already mentioned some of these areas, and I didn't bring here the taxonomy of users, but there is a taxonomy of different users. But scientists and researchers is one group, of course, that will study ecosystems, biodiversity, and climate change impact. and conduct experiments. You already heard that. Government and policymakers developing and enforcing environmental regulations. In Iliad, we have a specific, and you have this on your program also, that the policy component. So policy, of course, a digital twin will be a helpful tool for the politicians to develop new policies and also to monitor and make sure that we are all following regulations. But it's also important for the individual twins to know to have knowledge about the different policies. So it goes both ways there. Environmental organizations, they, of course, have a role in monitoring conservation efforts and assess the ecosystem's health and conduct advocacy and public awareness campaigns. Business and industry, there's a lot of business related to the ocean. It's super important. Mention here only offshore oil and gas exploration, sustainable fisheries and aquaculture management, shipping and maritime operations optimization, to mention just a few. Public and educational institutions, they need to raise awareness about ocean health and enhancing the programs with interactive ocean models. So how do we do this? How do we create a digital twin of the ocean? Well, this is a very simplification. First of all, before this schema here, you need to identify the problem you want to address. You need to identify who will benefit and eventually also who will be making, who are the actors in the value chain from the start to the end. But if we zoom in now here on the step where you are starting the data collections, you need to identify the different sensors, the IoT devices you need, and start to collect physical data on temperature, salinity, ocean current, and the specificity of the thematic and local twin that you are addressing or want to create. If it's possible to have research vessels and autonomous underwater vehicles, so can collect in situ data collections. You have drifters, you have gliders, and other instruments that are can be helpful, including drones. Actually, we are also including drone in Iliad. So then you need to prepare the data so that these data can be combined. And we have a whole section tomorrow, I believe, where we will address data management principles that will help you with that, and also standards and best practices, because you need to combine the real-time data with historical records and all the other different types of data that will go into your twin. You will use then big data analytics and machine learning to process and interpret these vast data sets. So you need to prepare the data to make it analytics ready, if you like. I will show you a more detailed schema later, so you see what that entails. Now, then you execute the modeling and the simulation. So either you have or you will develop mathematical and computational models that replicate the ocean processes. This varies also from thematic and local location of your twin. And then you run simulations to predict future conditions and test the scenarios, or but also visualization of all this vast and varied types of data. Prepare that for the right visualization is also part of, this is the next step, a part of the activity or part of the process of creating a digital twin. So typically you use, you want user-friendly interfaces with 3D visualizations, various dashboards depending on the user, and interactive maps, just to mention a few examples. And the stakeholders, the end users, will then be able to explore and analyze and manipulate data also potentially in real time. As I said, we can dive a little bit deeper into this schema. So on the left-hand side here, you see the observations and the data spaces, we call it. You see that we have data ranging from satellite data from space all the way down to submarine information, to bathymetry, to information data about the ocean floor and everything in between. You see listed here a few, I don't know if you can see my cursor partly. Some of these data repositories and databases should be well known, such as EMODNet here in Europe. We have Green Deal data spaces. There's a lot of and other data spaces that you want to use in your pilot. You have the European Open Science Cloud, with a lot of data that you want to use. Destination Earth, it's a digital twin of the Earth potentially. Destination Earth is also a place where you can find data. Copernicus, of course, with the marine services and other type of data that depending on your individual twin, and the ocean data information system managed by IOC. So a global data repository. So as I said, when you have all you decided, citizen science, I have to mention that citizen science is important and it's growing in importance to include in all the solutions that we are creating. Overall, the European Commission has the ambition of having us using like 20 or 30% of all the data should be coming from citizens generated data. So it's quite ambitious, and we are addressing that in Iliad. You have biodiversity, economic and ecosystem and various statistics type of data. And you have also simple, and it's that here represent the industry's digital twins activities. And we want to collect all of these, both the industry, the scientific, the governmental data, whatever kind of data you need to answer and to build a twin that will help you solve your problem and understand the ocean and the world, goes in here on the left side. Then you need to make it interoperable. So we have semantic interoperability. We need to prepare the data in various ways. And so we have a data lake for those twins that requires some heavy computational resources. Putting the data on a data lake is what you want to do. And Iliad has data lake being developed. And then you have EDITO, that's the European Twin Ocean you might have heard of, and we can come back to that later, but it's more like a met-ocean digital twin of the ocean in Europe, and a big initiative in Europe. Iliad is one of the components in this ecosystem building a digital twin of the ocean in Europe. Then you have a workflow engine and setting up the engine to run your processes. Then you have the visualization and the models and the tools go. You see here it goes in the loop. And finally, we spit out some services using also artificial intelligence and machine learning. In Iliad, we put everything here the front-end user interfaces and interaction is also, of course, an important component of this. Best practices and methods and standards is absolutely necessary, pivotal for making digital twins work. In Iliad, we make all of this available on the marketplace. And by all, I mean not only the individual twins, but the various components coming out of the different part of this pipeline here. Yes. Here we go, even more complicated. Yeah, I think you will be able to play with this during this week. And I provided this different layers of explaining what a digital twin is in this more from a high level to more detail, hoping that you will be able to use it. So you see here again in these red circles that you to recognize the different steps in the pipeline. So data acquisition and collection on the left side. Then you have data storage and preparation of the data. You do the analytics on using the data, do the analytics so that you will get out a service. And then finally, you have the interaction and visualization and the access to the end users. And you see there are many different steps that goes into this process. We will provide you with a small challenge or two where you can test out this system. The case studies, well, actually, in this the case studies that you will see some case studies later this week. We are particularly focusing on the energy, so renewable energy part, because Cork is an expert on renewable energy, ocean energy. So that's why you will see more detailed description of actual twins that has been built later this week. So what are the challenges and the future directions? The technical challenges is data accuracy. Actually, it's knowing, first and foremost, knowing the data accuracy and the integration and management of this. And there will be a section later, again, on data sharing and data management that will, where we will dive a little deeper into what that means. And developing high fidelity models and that accurately replicate the complex ocean processes is, of course, a technical challenge. We also do have some ethical and governance issues, data privacy and sharing concerns. That is definitely something that you have to relate to when you are developing a digital twin. And also, it's a challenge to ensure equitable access to digital twins technologies. We are not all starting from the same starting point in terms of knowledge or resources to use modern technology that goes into a digital twin. Future trends, advances in artificial intelligence goes without saying, and machine learning that will improve better predictions. An expansion of digital twins to more regions and applications. That is something that we in Iliad definitely are working to support. The components that we are developing in our multiple twins, we have some more than 20 twins that we are developing right now. And we are focusing on making the components, not only the twins themselves, but the components that goes into it reusable, so that more twins can be created to solve more problems. Collaboration between international stakeholders for global ocean monitoring is going to be a continuous challenge for us in creating digital twins as well. So you have now heard what a digital twin is. You have learned about the importance and the different benefits that comes out of creating digital twins of the ocean. Some of the technology, you have been introduced to some of the technology and current applications and the future potential. Digital twins will play a supporting role for sustainable ocean management and conservation without no doubt. So now I think we will open the floor for questions if you have. We will provide a list of more references and resources that you can explore further later. I don't have it here, but we will provide that on the Discord channel. So thank you very much. And you can contact me here anytime. And you can also contact me on LinkedIn or on other social media. Thank you very much.
Thank you. Is there any question? Yeah, you have one question here.
I don't know if you can hear me well. Can you hear me?
Can you hear the participant, Bente?
No, it was a blurry sound. Yeah, can you repeat the question?
Yeah, I will say that out loud again.
Yeah.
My question is in general because of specifically, let's say about the environmental transfer.
Do you want to come here, Bente? I will have the participants coming here
Yeah,
and
yes.
ask directly.
As you said, first thanks for the presentation again. So you said at the very beginning how complex our systems are, right? Especially also the ocean, and let's say now specifically for biogeochemistry, which will play a big role in these environmental impacts. We know that it's really hard to constrain many parameters and variables for the ocean on different timescales. Let's say something like fish stocks or even like carbon cycling and alkalinity and so on. And my question would be how we can, in this kind of data, fast data cycling, really replace the long-term work. Let's say the typical cycling in modeling is that over several years you try to understand how some variables change in different timescales and then implement that in a model, and that takes quite a long time. But now with this, it needs to happen really quickly. And the question.
Yeah, go on.
No, that's actually the question. So how does this happen now in this more faster cycling, and how can maybe the normal development contribute to this? Let's say.
Yeah. So the time scale here, it's I talked a lot about real-time data, but as a matter of fact, having those historical data and having a visualization of those, let's say the development that you were describing in the composition, say, and having that visualized in a meaningful way. I don't know the field well enough, but it's when you visualize this historical data from models together with newer information or together with anything else that you find meaningful that you can do with the digital twin, that's also a twin. You don't have to have this fast pacing update. So in the case of insurance for aquaculture, for instance. So the insurance companies, they have a lot of data on, incidents, historical data, say, that goes into their calculations of risk. Now, not all of those data are digitized in such a way that you can combine it with newer data, right? So you will, for a digital twin for insurance of aquaculture, which is the case, you can, as you get more of the historical data that you take out from your drawers, as you get that ready to be included in your twin, you are steadily then improving your twin. So what you are describing might be one of those cases where you can have historical data gradually improve the twin that you have. You see, so it's not necessarily that you have to fast pace, real time, update the twin. The twin, it's a digital representation of the physical world. And some of the data will be real time, but some of the data will be not real time, but data that you gradually get hold of as we are digitizing the information you have. I don't know if that answers your question.
Thanks. Well, I think I see nothing.
Thank you. Any more questions? No? Okay, so no questions.
Okay, thank you.